Hi everyone, welcome to this webinar recording of a session that we ran about a week ago on the formulation of CBD products and other botanical extracts. We're going to follow that up with a second short talk about the characterization of them, looking specifically at particle size and product stability. We're going to split this into two talks. It's going to be about 45 minutes in total. The first one, as we said, is about formulation using Ultrasound. We're going to be looking at CBD mostly for this one, but it's broadly applicable to any botanical extract. The second one is going to be about the analysis of these products to give some insights into particle size, bioavailability, and sort of shelf life and stability. When we did this live, we had a questions and answers session after each talk. Obviously, that's not going to be possible on a recording, so please do email any questions directly to me. That's my email address, dan@simon.co.uk. I'm going to give that again at the end of both talks, so no need to jot it down now. Very briefly, SciMed, who are we? Well, we are traditionally a distributor of scientific equipment. That was 40 years ago. We have evolved a lot now to a 30-person strong company. We have a very hands-on technical based approach, and we specialize in all of these areas here that you can see dotted down and more. We're very much cradle to grave, from sales all the way through to service to technical expertise in helping you develop your company processes and your new products. So a lot more than what we used to be, which was simply distribution. And I hope that's reflected in the sort of things I'm going to talk to you about today. This is just a brief overview, a couple of years old now, but a brief overview of just some of the products that we carry. So on to the first talk, formulation of CBD products and other botanical extracts using ultrasound. So let's get right to the whole point of what is driving us to do this whole webinar in the first place. The market's changing, and if you're watching this, then you'll know how much the demand for sort of hemp extracts and CBD oils and everything from these sort of food additives are just skyrocketing, and they reckon that demand in the USA alone is just going up and up and up. Concentrates have been legalized for sale in Canada and the UK. It's shifted a lot over the past year from being able to use full spectrum oils to not being able to use isolate, to now being able to use isolate and the Novel Food Act and all sorts of wonderful hoops we now have to jump through. But that doesn't change the fact that the market is absolutely rocketing. And that's what we're going to talk about today, and how you can get that edge in the market. What's driving this, or what's driving innovation? Well, just take one step back a little bit. Let's think about extraction. Used to be done very rudimentary by sifting keef, the pollen as you see here. As demand increased, methods improved to increasing yields and increasing volumes, extractions with rosin presses, with heat and pressure, just physically squeezing the oil out of hemp plants, and then through to alcohol extraction, which is still very, very widely used today. Of course, it doesn't stop there. We have innovated further, and we're now looking predominantly at ultrasound extraction in addition to alcohol extraction, still used, and supercritical CO2. SciMed are specialists in both supercritical CO2 and ultrasound extraction, so as long as you have your licenses from the Home Office in order, please give us a call, we can help with that as well. But there's also innovations in formulation, because not everybody has those licenses, not everybody wants to be a grower or a producer or an extractor. Some people just want to produce products. And what we're seeing at the moment is a trend. People going from what you see on the left here, this very sort of traditional, it's like a Silverstone mixer, it's just a great big stirrer, essentially, offering macro dispersions to using ultrasound, which changes the formulation slightly, gives nano dispersions. Yeah, what's the point though, really? I suppose, why not, if you want to make more product, why not just get a bigger stirrer and a bigger pot and make more? Well, this is the reason. We're now looking at fundamentally changing the nature of that product by going from what a traditional stirrer can do, which is a macro dispersion, taking liquid and liquid and just basically smashing it into each other to disperse it and break lumps up into smaller lumps, to nano dispersions, which is very, very different with ultrasound, and I'm going to explain why. First things first though, ultrasound, or is that ultrasonics? Well, it's both. They're interchangeable, but oddly enough, this is the question I get asked more than anything else when people hear about ultrasound or ultrasonics for the first time. Oh, isn't that the instrument used for scanning during pregnancies? Well, yes and no. You can see here the total sound spectrum. You can see that's where we can hear in blue, the acoustic range. Anything above our audible range is referred to as ultrasound. And you can absolutely see that this diagnostic and imaging equipment is in that range, but it's much, much higher up compared to what we're talking about today. That's in the megahertz region. What we're talking about, which is medical and destructive ultrasound, that's in the kilohertz frequency region. Yeah, destructive. That's what we call it. But don't worry, we're not chewing up all your product and destroying everything. It's traditionally called destructive ultrasound because of some side effects that has been noticed in real life, and we're going to come on to this. But what is ultrasound? What are we doing that's different to the imaging? Well, this on the right here is a titanium probe. It oscillates at between 20 and 30,000 times a second at a very small amplitude, maybe 50, 60 microns. When you dip that in water, it oscillates rapidly, and that oscillation causes changes between high pressure and low pressure areas. Where you get low pressure areas, it means very low pressure to the extent where you get vacuum bubbles forming or cavities. When those cavities are then hit by a subsequent high pressure zone, they implode, as you can see here, and it's that implosion that generates the intense shockwave that is associated with ultrasound. It's known as cavitation. You're already familiar with cavitation, believe it or not. I'm sure most people will have seen a propeller on a boat at some point, where you can see in the middle here these sort of jets of little bubbles spinning off the propeller. That's cavitation. Those are cavity bubbles being formed by the rapid movement of the propeller in the water that are then forming and exploding exactly as I just described. And it's very destructive. And you can see here, top left, looking at the damage it does to the metal of that propeller. There's a boat hull on the right hand side that you can see is warped and damaged, and there's pumps, there's gears. Can be very, very destructive. But what if we could harness that power, that destructive power, and apply it in a deliberate, controlled manner? That's what we're doing with our ultrasound instruments. And it depends on the intensity that you apply it as to what effect you get. So on the left-hand side here, we're starting off at low power applications. That is mixing, emulsification, dispersions. It's used in the cosmetics industry for dispersing fragrances, colors, formulas. In chemistry, you can see here it's no coincidence that there is an oil in water emulsion that I've put there, used for making biofuels as well. Turn the power up a bit and we have a different effect. This is where we'd be looking predominantly at extraction of hemp, where you can see there's that picture of a cell wall there, and the ultrasound can penetrate it, break it, the oil comes out. It's also good for killing bacteria, so things like pasteurization, for extracting RNA and DNA from cells, and even for paints, pigments and toners industry, for formulation of colorings and paints there. Crank the power up even further and we get to this top end, the high power applications, and this is where ultrasound really starts doing its destructive thing, and it just starts chewing up everything it comes across, from milling just waste streams to particle disintegration of zirconium oxides and titanium dioxide, milling of carbon black that goes into tyres. Fortunately, we're not dealing with either of this mid-power or high-power range today. We are talking simply about the low-power applications, and right in the middle there, this is where we are concerned with the formulation of CBD products. So what actually happens? We've seen what happens with a propeller and how that damages and how it spins off those cavity bubbles. This is a video of an ultrasound probe. Here you can see it's zoomed in on the probe. You can have a look at those bubbles forming. You can't actually see the probe moving, but because the liquid's coloured, you can actually see those cavity bubbles forming and exploding, forming and exploding. And when you zoom right in, it's almost like at a microscopic level that the liquid is flexing and it's moving, and that mixes things incredibly efficiently at a very, very local level. Far, far finer dispersions and mixing than you can ever hope to achieve with a macro stirrer. Just to show you how that really looks, just to bring it to reality, this is, put simply, some water in a glass, and we just poured some olive oil in it. I'm going to show you how efficient that mixing process is. So just imagine doing this with your oil in water emulsion with just a very low power probe, a 200 watt probe. We go up to 16 kilowatts, by the way. That's, you know, an awful lot more than this handheld probe. But you can see immediately there, olive oil in water. Yes, it's cloudy, don't panic. It's always going to be cloudy as olive oil in water, a little bit like milk. But we've just put quite a lot of oil in there, and you can see how efficiently, just within a few seconds, this is forming an absolutely finely dispersed, homogeneous emulsion. Just a few seconds left on that. There you go. That's what we're going to do with your CBD oil in, might be water, might be hemp oil, olive oil, MCT oil. It all applies. So remember when we talked about this, moving from the macro dispersions of stirring to the nano dispersions of ultrasound that I've just shown you? What that means in reality on a sort of chemistry level is this is what we're really talking about. We're going from simply stirring something round and round and round and hoping that it mixes well to form emulsions that are stable, to making sure that ultrasound does the job properly and we form nano dispersions. And despite what I've been told, size does matter, and that's demonstrated here. We're going to talk about the difference now between those oil globules that you'll get on the left, typically from just traditional stirring, where you get micro emulsions that are maybe up to 5 microns, 5,000 nanometers droplets forming in a typical oil in water emulsion. These are often created by chemical processes. They're dispersed using surfactants and all sorts of things, and sometimes that leads to a poor taste. The really important thing to do, though, is have a click on this link or try and access that link, and it'll bring you to this page, and it'll actually talk you through the relationship between the size of your oil globule and the absorption, and thus bioavailability. Here's the point. If you take CBD oil and you put it into a tincture, let's go for oil in oil for now, like hemp oil, olive oil, or MCT, just by normal stirring, you can't really get globules that are any smaller than 5 microns, and those large globules mean that they're poorly absorbed. You get less than 10% absorption. This is the current thinking, though. If we move to liposomal creations, or we move to the idea of dispersing your oil into water with an emulsifier to trap it into smaller micro-sized droplets and then disperse it throughout a product. That is quite popular at the moment because you can typically get nanometer ranges of about 200, 300 up to a micron. I think you get better absorption, but 20%, it's still not great. And this sort of formulation is typically what you see in the industry at the moment when people talk about water-soluble products. You see this in what we refer to as the lifestyle range of products, where people are making drinks, canned drinks, gummy bears, things like that. But again, this is using a sort of traditional mixer. It's using one of the big macro stirrers, and you're having to load it with emulsification agents and surfactants, things like polysorbate and tween that have bitter taste, and it really affects the product and it affects how people see it. It becomes viscous and dark and not pleasant. So here, this is what we can do with ultrasonics. We can mix, as hopefully you now believe, on a nano level, not micro, nano, and we can get a far finer dispersion. What does that mean? It means that you have better absorption and thus better bioavailability. So if we can really, that simply, as I just showed you in those videos, make a better bioavailable product with up to 50% absorption, how would the market react to that? I think it might be popular compared to the traditional standard oil with only 10% or less absorption. So how do you do it? Well, we can help. It's really easy. We have a facility, we have a number of units. 400 watt units is typical, as seen on the right hand side here. Happy to loan it to you. Just get your CBD, however you want to work with, whether that be full spectrum oil or isolate, a few beakers to work with or plastic containers, your carrier oil, whether that be MCT, hemp, whatever it is. If you're wanting to make a water emulsion, we can help with that as well. You'll need your emulsification agents like whatever you want to use. I've used the Lycothin here, polysorbate. You can buy them from eBay and anywhere else, not eBay, Amazon, anywhere else. But what's important to understand, the thing you need to ask yourself from the beginning is, what do you want your product to be? Is it a lifestyle product? Is it a drink? Is it a gummy bear? Is it something you rub on your skin topically? Is it something more traditional in a tincture? If you know what you want to do, then we can help. Equally, if it's water emulsions you want, which actually a lot of people still do, then we can help here as well. We have our sort of little basic recipe that we can give out to get people started. To say, this is the weighting we recommend of CBD, the weighting of water. And here on the right hand side, you can see in the sort of test tube there, I basically made a concentrated CBD in oil with my emulsifiers and various other things in it, which I used that amount of ultrasound power. I can explain all of that to you, what it means. And then I dispersed it just by taking some droppers and putting a few mils into that bottle of water there, and it just dispersed throughout and it tasted great. If that's the sort of thing you're after, we can do that. If you're wanting to look at something a little bit more traditional, we can do that with CBD oil in tinctures and things like that. So here's the sort of important bit to remember when going through this process. And in the next talk, please stay around, because I'm about to prove to you everything I've just said in terms of particle size and stability, why ultrasound is better. So ask us to loan units. That's fine, no problem. The really important bit is trials. Work with me, read the literature, optimize what you're doing, and then I will help you come up with your own unique product. If you like what you have, let us help you crunch the numbers about the cost of scaling up. Is it economical? And then finally, we can optimize and refine, and we can help you scale up to production. I've done this a number of times now with different companies for different products in different areas of the market. We're getting pretty good at it. But please, this is the key bit. Remember this very, very first step. Without proper investigation, you will never, ever get a product that you like or that's unique or where you want it to be in the marketplace. The point is this: ultimately, using ultrasound is just another way of mixing. It's not reinventing the wheel, it's just doing something far better than the industry has been doing for a long time. I can give you basic recipes, I can point you in the right direction, but I will never turn around and go, this is how company X, Y, Z do it, go copy them. I won't break NDAs ever. My job is to be your guide, to take you through, for you to optimize your process and ultimately make your unique product. It's about the three things there in combination, using Hilscher Ultrasound with our expertise and you to help you make your product.